72 hours, that's how much warning we had. On April 6th, 2026, astronomers spotted a house-sized asteroid hurtling toward Earth at 28,000 miles per hour. 3 days later, it passed closer to us than the Moon. And here's the part that should concern you. This object is on the European Space Agency's official risk list, not because of what it did this week, because of what it might do next. But before we get to that list and what it means, there's a number that keeps planetary defense scientists awake at night. A number that determines whether an asteroid strike kills thousands or kills millions, and 2026 GD just proved that number is way too small. Picture the scene. Monday, April 6th, a telescope in Arizona flags something moving fast against the background stars. Too fast. Within hours, observatories around the world swing toward the same patch of sky. The calculations come back. This thing is big, at least 50 feet across, roughly the size of a two-story house, and it's headed straight for the space between Earth and the Moon. The astronomers had a problem. They couldn't warn anyone because they'd only just found it. 3 days. That's the window we had to track this object, calculate its trajectory, and determine whether humanity needed to start making phone calls. Fortunately, this time, the math worked out. 2026 GD would miss us by about 156,000 miles. That sounds like a lot. It isn't. The Moon orbits at 239,000 miles. This asteroid crossed inside that boundary. It came closer to Earth than our own natural satellite. And while this was happening, 4 astronauts were floating in the Orion spacecraft, returning from humanity's first trip around the Moon in over 50 years. The Artemis II crew had no idea an untracked asteroid was sharing their neighborhood. Nobody did, until 72 hours before closest approach. Now, you might be thinking, 50 feet isn't that big. You'd be right to wonder. An asteroid this size wouldn't end civilization. It wouldn't even make the evening news if it hit the ocean. But here's what 50 feet of rock moving at 28,000 miles per hour actually does. Remember Chelyabinsk, February 15, 2013. A 60-foot meteor exploded over a Russian city with the force of 30 Hiroshima bombs. The shockwave blew out windows across 6 cities. 1,500 people went to the hospital. And that object was only slightly larger than the one that just passed us. The difference between a close call and a catastrophe came down to a few degrees of trajectory. We didn't see Chelyabinsk coming at all. Zero warning. It approached from the direction of the sun, completely invisible to our telescopes. At least with 2026 GD, we had 3 days. But 3 days isn't enough. Not nearly enough. And that brings us to the risk list. The European Space Agency maintains a catalog of every known asteroid that has a non-zero chance of hitting Earth. It's a database of cosmic bullets with our name on them. 2026 GD is on that list. Not at the top. The calculated odds of impact are roughly 1 in 124,000, spread across several close approaches between 2082 and 2124. Those are long odds, but they're not zero. Here's what that actually means. Every time 2026 GD swings back through the inner solar system, it plays Russian roulette with our planet. The next encounter is July 2031, when it'll pass at a much safer distance, about 25 times farther than the Moon. But orbits change. Gravitational interactions with other planets can nudge an asteroid onto a different path. The object that misses us by millions of miles in 2031 might miss us by thousands in 2087. This is why the 72-hour window matters so much. NASA's planetary defense strategy depends on early warning. The plan isn't to blow up incoming asteroids like in the movies. That just creates a shotgun blast of smaller rocks. The real plan is to find threatening objects years or decades in advance, then send a spacecraft to gently nudge them onto a different trajectory. The DART mission proved this works. In 2022, NASA deliberately crashed a probe into the asteroid Dimorphos and successfully changed its orbit. But DART only worked because we knew where Dimorphos was. We'd been tracking it for years. We had time to design a mission, build a spacecraft, and intercept the target. 72 hours gives us nothing. No time to launch, no time to nudge, no time to do anything except watch and hope. Think about what happens if the next 2026 GD isn't a near miss. Think about what happens if a house-sized rock is headed for Chicago, or London, or Tokyo, and we only find out 3 days before impact. There's no evacuation plan that moves 10 million people in 72 hours. There's no shelter that protects against an airburst equivalent to a nuclear weapon. The Chelyabinsk meteor injured 1,500 people in a region with low population density. If the same object had arrived 4 hours later in Earth's rotation, it would have detonated over Moscow. And that's the uncomfortable truth this flyby exposed. Our detection systems have massive blind spots. Objects approaching from certain angles, particularly near the sun, remain invisible until they're almost on top of us. Small asteroids under 100 feet can slip through our surveys entirely. We've cataloged most of the civilization-ending asteroids, the ones a kilometer or larger. But the city killers, the ones that could wipe out a metropolitan area with no warning, we've found maybe 40% of them. 2026 GD didn't hit us. It wasn't going to hit us. The trajectory was never a threat, but it was a test of how much warning we'd actually have if something similar was on a collision course. 72 hours. Remember that number I mentioned at the beginning? The one that determines whether an asteroid strike is survivable? This is it. Detection time. Warning time. The gap between we see it coming and it's here. NASA estimates that 10 years of warning gives us options. 5 years, we can probably still deflect an incoming object. 1 year, it gets dicey. 72 hours, we watch it happen. The good news is that space agencies are working on this. The NEO Surveyor mission, scheduled to launch soon, will hunt for asteroids from a position closer to the sun, covering some of our current blind spots. New telescopes coming online over the next decade should dramatically increase our detection capabilities. The bad news is that 2026 GD was a reminder of how much we still don't see. So here's my question for you. Knowing that objects like this pass closer than the moon several times a year, knowing that we sometimes only get days of warning, what would you do with 72 hours? Would it change anything? Would it change everything? The universe doesn't send warning shots, but this week it came close.